Hello students, in this video we are going to learn how to find the derivative of given integral function using the second fundamental theorem of calculus. So let's look at what the second FTC says. It says if fx equals integral from a to x of some function in terms of some other variable, say this is t, f of t dt, then f prime x, the derivative f prime x would be just the function but not in terms of t anymore. It would be in terms of x, the upper bound, the variable which was present in the upper bound. Let's start with an easy example. See, we are given the integral function, this one, sine of t dt. Then what would be, okay, first we need to check the conditions. Is the lower bound a constant? Yes, the lower bound is a constant. It's a pi over 2. Is the upper bound a function of x or just x? Yes, the upper bound is an x, which is same as this. These two things should match. So what we need to do to find the derivative, we know that derivative and integral both are the inverse of each other, opposite of each other. They cancel each other. So this integral sign goes away and just the function, but not in terms of t, in terms of x, what the upper bound was, and you are done. See how easy it was. Let's make it little more complex. Let's see how to work on a problem when the upper bound is a function of x. Instead of x, it's some function of x, and the integral function is also a little complex. Instead of sine t, it is sine t cubed now. So the lower bound is a constant, upper bound is a function of x, and the integral function is given in some other variable. That means we need to apply FTC. And what we do, we just replace the variable t. Earlier we were replacing t with x, but because the upper bound was x. But for this problem, we are going to replace t with the upper bound, the whole upper bound, which was a function of x square plus 9. Since it was t cubed, so it becomes x square plus 9 cubed times, we always write the derivative of upper bound along with. This is a short way to solve these kind of problems. So what we do, we just replace the variable t with the upper bound and take the derivative of upper bound along with. Let's simplify it a little more. We don't need to expand the cube, so we can keep it x square plus 9 cube, because this is angle of sine, just like sine theta. This is sine of x square plus 9 cubed. So all this is theta. We don't need to expand it. Then the derivative of x square plus 9 is, derivative of x square is 2x, derivative of constant 9 is 0, and then we simplify it a little more, write the 2x in front to make it look beautiful. Sine of x square plus 9 cubed. So this was the derivative of given integral function using second FTC. So it was so easy. In next video, we are going to work on a problem when both upper bound and lower bound as well, both are given the functions of x. So how we solve them. So stay tuned for our next video. Take care. Bye bye.